Good evening, everyone. Am I audible?
Yes, ma'am. You're audible. Good evening.
Okay. So we'll wait for more
Yes,
minutes, right? 5 minutes, and then we'll start. Just let
Um,
me know when to start, right?
sure. We'll start at 7:10.
Okay, fine.
now, we can start now.
Yeah, okay, Amar. Thank you. Okay, good evening, everyone. Okay, so yesterday we completed with functions, right? So we have understood what is the function definition and declaration, what are the function parameters and return types, call by value and call by reference. And finally, we have done what are the recursion functions, okay? So today we will be understanding about pointers, okay? So what are pointers? Then what are the various operators of pointers, arithmetic, then how you will be using pointers and arrays, which already we completed, pointers and strings, pointers and functions. Then what are the void pointers and what are the constant pointers, okay? So today we'll be going through pointers, and yesterday, okay, there was a request of showing the Armstrong number. So we have just discussed the flow chart. So today we will be writing the program first for that, and then the discussion on the quiz. Okay, so I have got only the questions. Okay, so the output type of the questions we will be understanding. So we can also, write the questions and we can test them. Okay, so first let us do the Armstrong example. Then we will go with the quiz questions, and then we will start with the pointers. Okay, so I'm going to share my screen, and let me know the screen is visible. Okay. So I have shared my screen. Let me know the screen is visible to everyone. Okay. So yesterday we had just understood what is the Armstrong number. Okay. So what is the Armstrong number? If you consider this number, and if you are going to these are 3 digits. Okay. So 1 raised to 3 plus 5 raised to 3 plus 3 number. Now this is known as the Armstrong number. Raising the power to that number.
There is some network issue at your. Can you please check this?
Yeah. Okay. So like number of digits. So if this is 4 digits, so you will be using 1 raised to 4, 5 raised to 4, 3 raised to 4, 2 raised to 4 like that. Okay. So you should be getting the same number. That is what is the Armstrong number. So we have seen this particular algorithm. Okay. Now we will write the code based on this algorithm. Okay. So let us go for the notepad, and here we will start writing the code. So hash include stdio.h, and for this we will also need the math. Okay, so I will be including the math.h library as well. Okay, so let us save this in the C programs. Okay, so I'm directly saving this here by the name of Armstrong number. Okay, so let us go for day 9. Okay, so this will be the Armstrong number. Okay, dot C. Okay, now let us start with the main method. Okay, and we'll create some variables. So int num. Okay, so int num, we need a number. Okay, for taking the number, then we need the temp also. We need to do the sum also. Okay, so then we will have the temp. We will have n initialized to 0. We will also have the digit and sum initialized to 0. Okay. So first of all, we need to ask the number. Okay, input the number. So we will ask the user printf enter a number. Okay, scan %d address of now. Then in the temp variable, we are going to store this number. Okay, in the temp variable, we will be storing. So sum is already initialized to 0. Sum is initialized to 0 and temp will be having the num. Okay, then we need to count the number of digits in num and store in n. Okay, so we will count by using the loop. Okay, that already we did with characters. Okay, now this time we will be doing with this particular number. So this is done. Okay, now let us count the number of digits. Okay, count number of digits. Okay, so while temp is not equal to 0, okay, we have already done this in the reverse example earlier. So n plus plus temp divide by equal to 10. Okay, just go on dividing by 10 till you are not getting the quotient as 0. Temp is equal to now. Okay, so here we will be getting the total digits. Okay, num anyways we are storing in temp here. Now we need to calculate the sum of digits. Okay, so repeat until temp is not equal to 0. This we have done. Extract the last digit. Temp mod 10 add digit. Remove the last digit. Okay, and now let us do this calculation. So calculate the sum of digits raised to the power n. Okay, because we need to raise every digit to the power n. Okay, that is n is nothing but it is the total number of digits we have got. Okay, so while temp is not equal to 0, okay, while temp is not equal to 0, so we are now performing this. Okay, we need to do the fifth step, repeat until temp is not equal to 0. So we have done this reverse example. Okay, in the reverse example. Okay, the same code we are going to write here. So digit is equal to temp mod 10. So you have to use the modulus operator. You are getting the remainder. Then sum plus equal to, now POW, this power function is available in the math.h. Okay, and that is why we have to make use of this power of digit. So every digit we need to raise to the power n. Okay, and we need to do the sum of that. And then again, you will be using temp divide by equal to 10. Okay, this is the logic. So every digit you need to raise to the power of n. N is nothing but the number of digits. So understand one thing here. Again, I'm telling these are 3 digits. Okay, so first we have found out the number of digits, that is nothing but n. Now every digit we need to raise to the power of 3, and then we need to go on adding that. Okay, so this is what we are doing. Sum plus is equal to power digit comma n. So digit raised to n. Okay, so you have to make use of this function which is available in the math. If sum equal to num, now compare sum with the num. Okay, so if your sum is total to the number itself, then it is an Armstrong number. Okay, so printf %d is an Armstrong number. Okay, now else you will print it is not the Armstrong number. Okay, so this is, it is not an Armstrong number. Okay, and then since this is a main, I can write here return 0. Okay, so this is Armstrong number. Now let us open the command prompt. See, you can open the command prompt from that particular directory also, okay, where you have saved that file. So in the C programs, I have got in the day 9. Okay, so this is Armstrong number. So you can just select this path above. Okay, once you select this path above, so CMD, you type CMD, that is the command prompt. Okay, so when you press enter, you will get the command prompt open with this particular day 9. Okay, with the day 9. So you don't have to write the path here. Okay, now I will be using the GCC and just press a tab. Okay, so enter a number. So if I give 152, okay, 152 is not an Armstrong number. But if I give 153, okay, this is an Armstrong number. So like in this case, okay, we have got the different digits Armstrong number. Let us check with the 370. 370 is Armstrong number or not? Okay, it is an Armstrong number. If you go with the 4 digit, 1634. Okay, so 1634. It is an Armstrong number. If I'm writing 1631, it is not an Armstrong number. So these all are the example of the Armstrong number. Okay. So this was the query. I hope this is understood. Okay. Arpita, this was your query. Yes. Okay. Good. Now let us come to your queries. I only have the questions, but let us, go through the questions, right? So this was your quiz questions, correct? What will be the output of the following C code? Okay. Now, in this case, if you will see, x is 5, y is 10. If x is greater than y, okay, if x is greater than y, okay, then only it should come inside this loop. Now, this condition itself is false. So it will directly go to the else condition and you will get here the output as C. Okay, whatever is the condition here, this condition has to be true. Then only it will get inside this if block. Now this condition is false. So it will directly go to the else of this particular if. So the output of this will be C. Okay, that was the question. Okay, now see, there is the question on switch case. Okay, first of all, there may be some statements, but I will let you know that switch statement can have the case with an integer value, okay, with some expressions and with your character also. And one case statement can have multiple values also. Okay, so this particular question and the last question here, okay, now understand, this is A equal to 2, B is equal to 3. Okay. Now switch A plus B. Understand A plus B is what? 5 because 2 and 3. So that means even in the switch you can write the expression. Correct? And now here what is 5? 5 is this. Okay. So printf 2. But if you are not writing the break after the case statement, it will also go to the next case statement. So in this case, the output will be 2 and 3. And after 3, there is a break. Okay. So if break is not written, it will go to the next case statement. So if this is 5, okay, then 5 is this particular case. Break is not written. 2 output will be there and 3 will also be there. After 3, there is a break. So the answer for this is 2 and 3. Okay. So now let us come to the switch case statement again. Okay. What I will do, I will write one particular code here again. So let us say that, okay, this may be, I will write all your quiz questions here. Okay. How the switch case can be written. That is important. Let us give this as test.c. Okay. Right. Test.c. Let us take an example where user is giving the month number. This already I have shown earlier, maybe, but I will make some changes later in that code. Okay. One multiple case can have one output. Okay. This was one of the statement. Multiple case can have one output. That is correct. Okay. So let us say that I am creating a month variable. Then I will ask the user to enter month number. Okay. And then we will be taking that number. So percentage D. And here we are going to write add of month. Okay. And in the switch case, I'm going to use the month. Okay. Now see here. We will have case 1, that is a Jan month. Okay. Case 3, March. Case 5, May. Okay. Correct. Let us say case 8. So you can write some particular cases. Now all these months, okay, example, will have 31 days. Correct. So I can write printf month contains 31 days. Okay. So whether user is giving first month, third month, fifth month, eighth month, okay, the number of days will be 31. Now, if user is going to give case 2, okay, so yes, after this, you need to write a break. Okay. Then case 2 is there. Okay. So case 2 means what? Either it can be a leap year or not. So here, actually, you can call a function which is checking whether a year is a leap year or not. And this we already did in the conditional construct examples. Okay. So now general statement I'm writing. Month can have 28 or 29 if leap year. Okay, so I'm just giving a general statement here, but you can do the calculation of the leap year and you can say that it contains 28 days or it contains 29 days. Okay. Then whatever is the rest of the month that you can write it down here. Okay, like we have got case 4. Okay, or we have got case 6. Okay, case 7, something like that. Okay. Now, what you can do here, you can give the printf that month has 30 days. So what is done here? Multiple case can have one output. Okay, example I am giving you. And in the default, finally, you can write, I'm forgetting the breaks here. So just give a break statement. Otherwise, you will get an error. Okay, so here also we will have a break. Okay, and then you can write the default statement. Okay, and then I will just give the output as invalid month number. Okay, so this is invalid month number. Okay, so this is how you can have the switch case written. Now let us just go ahead and execute this. Okay, so I will be using GCC test.c. Okay, so if I will enter the month number, okay, let us say 3, I'll get month contains 31 days. If I give 1, I'll get month contains 31 days. So multiple case can have one output. If I'm giving 2, I will get month can have 28 or 29 if leap year, correct? If I'm giving 4, 6 or 7, I will be getting month contain 30 days, correct? And if I'm giving any other number like 13, I will get invalid month number, right? So multiple. Now what you can have, so here we have seen that you can have the expression like in the last question, you are having that is correct. Okay, you will get the output 2 and 3, right? Can we write an expression here? Yes, you can write the expressions. What? Let us say this 1 is nothing but it is 0 plus 1. This is correct. Okay, if you will write here, let us say instead of 3, I am writing 1 plus 2. This is correct. Instead of 5, I am writing 1 plus 4. Okay, instead of 7, I am writing 1 plus 7. Expressions can be written. Okay, expressions can be written. Then you can also have something like this. If you are writing case A plus 2, see, this is also okay. Why? Because A plus 2 means what? ASCII code is going to be taken. ASCII code is going to be taken. Okay, so here you can have some particular printf statement written. Please understand, all this is allowed in the switch case. Expressions are allowed. But the only thing is if break is not written, it will go to the next case statement. Okay. Then what else we were having? Yeah, what is the output of this? Int n equal to 0. If n is equal to 5, printf hello. Now understand here. This particular expression, what is written here, is not the comparison. It is the assignment. So if n equal to 5, that means what? It is not comparing. It is not written equal to 5. It is written n equal to 5. So what will be the output of this? Okay. So let us say that I'll copy this code. Okay. And I'm going to comment this part. You can write this in the function also, but okay, one by one we will see the output, right? And here I'm going to paste that. Okay, so we have got if n equal to 5, printf hello else. Okay, printf world. Now understand that this is the output in this case. Okay, I don't have the outputs here. Okay. So this should be closed. Let's remove this. Okay, so case ka close has to be there. So let me close this and then I'm going to comment out this, right? Fine. So let me compile this once again. Okay. There is no output here. There is no error. There is no output here. Okay. So this is going to be true. You are getting hello because this n equal to 5 is there. There is no condition. This will be true always and you are going to get hello. Okay, so in this case, you will be getting the first output only, right? This is nothing but it is not comparing. It is just assigning n is equal to 5. So this will be holding true and you are getting hello, right? If you are writing n equal to 5, then what? Let us see. It will take some time. Now I'm getting world. Why? Because now it is comparing. Okay, so if equal to is there, then it will go to world because the condition is false. If n equal to 5, then it will print hello. Okay, it is always true. Then most appropriate conditional structure for selecting the smallest of three numbers. Yes, we have done this logical and okay. Yeah, predict the output. Now in this case, I is 0, okay, and I plus plus is less than 3. See, usually, okay, how we are writing the while loop. Okay, so if you go back to this code, okay, so let us comment this also. Okay, let us comment this. Now, if you are writing the while loop, you are giving some condition and here you are giving the increment or decrement. Okay, now here what is written in the question, it is int I 0, but increment is done here itself and this is post increment. This is post increment. Okay, so let me copy this. Okay, so you can you have to try this, okay, and run and see what output you will be getting. Now understand, first of all, increment is done in the header itself and this is post increment. Okay, that means first the execution will happen and then the increment will happen later. Okay, it is not pre, it is post. So let us see what is the output of this code. Okay. 1, 2, 3. Same. So I is equal to 0, I plus plus 1. Okay, then it will be printing because it is done later. Okay, so this is incremented. So 1 is less than 3, it will print that. Similarly, it is 2. Okay, then it will print this I 2. Okay, then again here it is going to increment later. That is why it is going to print. Okay, now if you are going to use the pre, okay, if you are going to use the pre here, so this also can be written not only inside the body of the loop. Okay, 1 and 2. Okay, because first only this value will be printed. So this will not give you the 3 value because after this is printed. Okay, and then this will be incremented before first this will get printed. So now here you are getting 1 and 2. Okay, so this will differ in the output. Okay, because this is post. So once it is added, it will then give you the value, but not in the case of pre. So this is the output of that. Okay, 1, 2, 3 was output. You are developing a sensor reading system that must run continuously until the user presses Q. Which loop structure is best? Infinite loop. Okay, whenever you need to control, the loop is running infinitely, and then when you press Control C or quit, when the user will give quit Q, then that particular loop should stop. Okay, so I think that is the infinite loop. Which of the following will not execute even once if the condition is false initially? That is the while loop. Okay, so whenever you are using a while loop and you are going to give a condition, this condition, if it is false, okay, then your while loop will not run. Okay, that we have seen earlier. Now, predict the output. Okay, fine. Let us run this. So this also I will comment out. Okay, so int I equal to 0. Then we have got while I is less than 3. If I equal to 1, break. Printf percentage di and then I plus plus. Okay, now this is breaking the loop. Fine. Now, what is the value of I? It is 0. 0 is less than 3, true. If I equal to 1, then break. Okay, so otherwise it should print the output and then it is incremented. It is 0, it will be 1. Okay, so what will be the output in this particular case? So let us run this and see. You will get 0. That is correct, no? Because this is 0. This is not 0. This is 1. So it will not break. It will print the value 0. Then it is incremented. Now it will be 1. So 1 is less than 3, true. Now I equal to 1, yes. Now the loop is going to break. So the output is only 0. Okay. Then let us do this. Okay, we need to predict the output of this. Because the options are not given. Okay, but now see here. A is 1, B equal to 1. Okay. Now there is a nested while loop here. Correct. There is a nested while loop. A is less than equal to 3. Yes, this condition is true. Understand, this condition is true. If this condition is true, it will come inside this while loop. Okay. Now while B is less than 3, this is also true. This is also true. Okay. Now print F this asterisk. Okay. So this will be printed. Now A plus plus. Okay. A plus plus. That means A is going to be 2. Okay, now 2 is less than 3. Yes, 2 is less than 3. Now come here. B is less than 3. Yes. Okay. So now this condition is also true. But understand, only A is getting incremented and not B. B is not getting incremented. Here only A is getting incremented every time. Okay, what about B? So how this condition is going to be checked? So if you will run this, okay, you will get the infinite loop. Why? Because B is not incremented. So always B is going to be less than 1 only. Okay, sorry, less than 3 only. It is not incremented. So this is getting into the infinite loop. Okay, only the outer A plus A is checked here, but B is not checked. So this condition is going to be true. Okay, so it is just going to print that, right? Fine. So these are some of the questions you got in the quiz. I hope this is clear now. So you need to check, okay, what will be the output when the code is given. Okay, is this clear? Everyone, is this clear? Okay, your quiz questions. That was a doubt. Now let us come to our new topic, okay, which is pointers. So let us understand the pointers and how to work on the pointers. Okay. Now pointers are used in C. Okay, these are going to access the memory address. Okay, directly. A pointer is a variable that stores the memory address of another variable. Okay. So instead of holding a digit or a value, it will point to the location where the value is stored in memory. Okay, so memory manipulation can be done using C, pointers. Now pointer is declared using this asterisk. This is also known as dereferencing. Yesterday we done, okay, that is pass by value and pass by reference. Okay, so in pass by reference we are using this particular dereferencing. So what you have to do, you have to declare the pointer with the data type. Okay, so star indicates that the variable is a pointer. That means it is pointing to a location, to a memory location. Okay, the type specifies what kind of data the pointer points to. So pointer is pointing to a integer data or the float data, what type of data? Okay. So if you are having the pointer by the name of PTR, usually it is a PTR. Okay, so this pointer is having the address, and the pointer itself will have its own address because everything is there in the memory, right? So pointer is having its own address. So this is the address of pointer variable. But pointer is storing what? Pointer is storing the address of some other, okay, location, okay, where the value 10 is available. And this value is given 10 for the variable where. Okay, so value of variable where that you can get by using the star pointer. And this is the address of variable where. Okay, so the address of where is this, but this address is stored in the pointer. This address is stored in the pointer. Okay, so what you can say that pointer is a variable which is storing the address of another variable. It is pointing to the address, okay, where some particular data is available, correct? So now let us see how you will be declaring this pointer first, and then we will go for the pointer operations. Okay. So let us go to a new file and we will, use the simple declaration of the pointer here. Okay. And then how you are going to retrieve that values. So this is the pointer. Okay. I'm simply going to save this file as the pointer.c. Okay. This is pointer.c, right? Very simple examples, okay? Understand. Int where is equal to 10. Okay, so there is a variable by the name of where, and I'm initializing the value 10. Okay, so this is a normal variable with value, okay, 10, correct? Now we are creating a pointer of type integer. Okay, so this is the pointer declaration. This is the pointer declaration. Then pointer is equal to address of A. Okay, pointer is equal to address of A. So what the pointer will have? Pointer will have the memory address of this variable. Okay, that is where. Okay, not A, that is where. Okay, so look at this diagram. Okay, so pointer is having the address of this particular where. Okay, so how you will get the address of the where? By using this at the rate address where. So this is going to have the address. Okay, so this is what pointer stores address of where. Okay, so int where is equal to 10. This is this. Okay, where has got the value 10. Okay, we are defining int star pointer. Why? Because this pointer is pointing to the memory which is having the integer value. Okay, so we are having int star pointer. Now pointer is pointing to the address of where. So pointer is pointing to the address of where. Okay, which is integer. So int pointer is created. Now simply, okay, you want to get the values of this, right? So we will simply use the printf statement here. Okay, so value of A where will be %d, and this will be the where variable. Similarly, let me copy all this. Okay, so first of all, where this is going to give you 10, then address. If you want to get the memory address of a variable, you will write address of where. Okay, so we have now, okay, we will be now giving the value of where, which is 10, and we should give the value of address. Okay, that will be some address, this particular address, this one. Okay, now let us go to the pointer. Okay. So value stored in pointer, value stored in pointer PTR. Okay. So this you will be using %p, and here you will write pointer. Okay. So what is the value stored in the pointer? And here we will be writing value pointed by PTR. What PTR is pointing to? Okay, so this will be D. And when you want the value of the variable what the pointer is pointing to, you should write this star PTR. Okay, dereferencing, right? So let us check this now. Only this much we will write. So this is a pointer. Okay. Look at this. Right? So if I will take this particular diagram, okay. So value of where, okay. So what we are getting value of where? We are getting the value of where is 10. We are simply displaying where, okay. Address of where, what we have written? Address @ where. So this will be some particular address in memory, okay. Value stored in the pointer PTR. In the pointer, we have got the address. Okay, so what we have used? PTR P. So it will give this particular some address. And value pointed by PTR is 10. This pointer is pointing to the memory location which contains the value 10. Okay, so that is star PTR. Now, if you are using here also, instead of P, you are using D. Okay, that you want that in the decimal. Okay, you want that in the decimal. So this address and this address is same only. Okay, see here. So the address of where and what the pointer is storing is the same address of where. So this is going to be same. And star PTR means the pointer is pointing to what data in the memory location. So this and this is same. Okay, 10. So this is how the pointers, okay, will be pointing to, okay, specific memory location. Now using this only, we will be moving further. Okay. Now next is pointer operators. Okay, just now we have seen that what are the operators we have to use when we are working with the pointer. So we have got @, which will be address of the operator. And star, this is value at operator. This is known as dereference. Gives the value stored at the address. Okay, it is dereferencing and giving the value. So when you are using PTR is equal to address of A, it is going to store the address of the variable A. And X is equal to star PTR. That means pointer is pointing to the memory location, that location ka data, that location ka value. So that is what is star PTR. Okay, now these two operators are used, correct? Now let us understand the pointer arithmetic. Okay, now what is pointer arithmetic? Pointers support arithmetic operations such as increment and decrement. Now this we have done, okay, previously. What we have done with the plus plus and the minus minus, okay, operator. Incrementing a pointer moves to the next memory location of its data type, like we have done in the case of arrays. Okay, if you are declaring an array of the type integer, it is having 4 bytes. Okay, so your contiguous memory location will be 4 bytes. Okay, if it is a character, it will be 1 byte, right? So same here also, it depends on the data type. Okay, now there are some rules what you need to follow in the pointer arithmetic. So P++ moves pointer to the next element. Okay, P minus minus moves pointer to the previous element because it is minus. So it will go to the previous element. P plus N moves N elements ahead. So if you're writing pointer plus 2, so it will move 2 elements ahead and give the output. P minus N moves N elements back, okay, because it is minus. Pointer arithmetic depends on the data type size. If int is equal to 4 bytes, pointer plus plus increases the address by 4 bytes. If char, then it is going to be 1 byte. Float, it will be 4 bytes, like that, okay? So it depends on the data type size, okay? This is very important. Now let us write the pointer arithmetic code and understand this, okay? So I'm going to create an int main, okay? Let us take an array. So int add, let us have 5 numbers, is equal to, okay, we can have the array with this particular values, okay. Let me save this first. So this will be the pointer arithmetic, okay. See, we did with the arrays, okay. We have traversed the arrays, but now we are doing this with pointers, okay. Now, how the pointer is going to point to the array. Okay, so when you are writing int star pointer is equal to add, okay, this means same as add of address of add of 0. Okay, now see this. Why int pointer? Because we are using integer type. Okay, the values are of integer type. So int pointer is equal to add. That means the pointer is pointing to the address of the first element. Okay, so address, instead of writing address of add of 0, even if you are writing only the add, that means it is pointing to the address of the first element of the array. Okay, variable we have done earlier. Now this is the array. Now let us perform the arithmetic operations. Okay, so I'm just going to have the printf first element. Okay, first element percentage d /n, okay, star pointer. Now this star pointer, which is pointing to the address of the first element, okay, the first element is 10, okay, so it should keep 10. Fine. First let us check this. So pointer arithmetic, then I'm going to use the other operator. Okay, so pointer arithmetic A. Okay, so what we are getting? The first element we are getting is 10 because star PTR points to the address. Okay. Now I'm going to use the pointer plus plus. Okay, we are incrementing the pointer. So this is going to move to the next element. Okay, this is going to move to the next element. Correct. Now we will print the second element. Okay, let me just write this. Okay, and fine. If you are using minus minus, okay, let us go to the previous element. Okay, so here we can write the next element. Okay. Okay, so %d/n, this is star tr. Okay. So let me first see whether we are going to get the minus minus and plus plus. Okay. Okay, so you can see your first element is 10. Okay, so because it is pointing to the first element, right? Then next element, it is going to 20, and then I have again written go back. Okay. So here we are getting element at the given location. Okay, let us do one thing. I will write at the, so let me just write it down here. Pointer, because it is at 0 only, na? So I can write pointer plus 3. Okay, let us see what output here I'll be getting. Because at the pointer in the dereference, okay? So either you can write it down here and give the value. So directly I'm writing it down here. Okay, so pointer plus 3. So now element at given location is 40. Okay, so it is in 10. So 3, we are doing plus 3. So it will move 3 location and I'm getting 40. Okay, so this is how the pointer arithmetic works. Similarly, you can write minus and then you see whether it, which location it is going to, because you can write minus also. Okay, so pointer minus, let us say 2. Okay, so let us copy this and let us use pointer minus 3. Sorry, minus 2 I meant. Okay, so let us check this now. Okay, so what we are getting? Okay, let me reset the pointer. Pointer is pointing to 0, right? And that is why minus is not giving me the output. Should give the value, okay, because it is starting from this. So let me just write arrow for it is a star only, okay. let us do one thing. This should give the value. If I'm going to increment this again, so what value it will give me? So let us say it is in 40. So I will increment this by 1. Okay. So let me check. It is always starting from 0. Okay. That is why it is giving me the value as 20. Okay. So in that location, there is a memory address. So I'm getting memory address when we are dereferencing it. Okay. Because we are not moving. Okay. We are not moving that. So if I'm writing the pointer plus plus here, okay, then you will get a different output. Then you can use the dereferencing and get, now I'm getting 30. Okay, because I have incremented the pointer and then I'm writing pointer plus 1. So I'm getting 30. Okay. So now if I will write here pointer minus 1. Okay. It depends. You have to reset the pointer, then you again write pointer is equal to air. Now I'm getting 10. Okay, now this minus will work, correct? Because I have incremented the pointer. Now pointer is pointing to 20. So now when I'm writing minus 1, it will be going backwards here. Okay, to 10, correct? So this is how you can use the pointer. The only thing is, yes, where currently the pointer is pointing, that you should know. Okay, and depending on that, then you can increment or decrement. Okay, let us see. Okay, Chetan. Yes, right? Fine. So you have to see that where currently the pointer is, right? And then you have to perform that operation. So this was the pointer arithmetic. Okay, so remember the rules, okay, to follow. Now coming to pointers and arrays. An array name in C acts like a pointer to its first element, and that is what we have done here. Okay. Air and address of air of 0 both point to the first element. Now let us iterate using the pointer. Okay. Let's iterate using the pointer in an array. So let me write here the main method. So let us define the array again. Okay, so I'm having the array of 5. And let us have the same values. So 30, 40, and 50. Okay, let us save this. This is pointers and arrays. Okay. Now int pointer star ptr is equal to air. So this is okay, right? That is what we did in the pointer arithmetic. So it is pointing to the arrow of 0. Okay. Now let us access this array using the pointer. Okay. So accessing array using pointers. Now look here. We are already done with the loops. Okay. And we have already traversed to the array. Okay. But directly we are displaying the values. But now we will be displaying this value using the pointer. So int I is equal to 0. I is less than 5. Yes, you can find out the size that we have already done earlier. I plus plus. Okay. And now here air of percentage D. Okay, like air of 0, air of 1, air of 2. Now, dynamically, we want to display air of 0 contains what? Air of 1 contains what? So, percentage D can be written in this air dimension also, correct? So, air percentage D is equal to percentage D, okay, star pointer plus percentage D. Please understand the output later on, okay? We are using the pointer and we are using the percentage D with the array is equal to percentage D slash N, okay? First of all, I value will be there, air of I, and then star pointer plus I. Okay, now look here. We have got 4 percentage D. Okay, we have got 4 percentage D. Yeah, I'm showing the program. Just see this. This is the program. Vinuta, which program you want to see? Current program which we are doing. Okay, it is only this much. Now, there are 4 percentage D written in this particular statement. Okay, 4 percentage D. So we need to provide the value for that 4 percentage D, correct? Now, what is the value of I? That is the index of the array, correct? So I is 0. That means here you will be getting air of 0, air of 1, air of 2, like that, okay? Then the second is air of I. So percentage D, this should give me the value of that particular index, correct? So it will be 10, 20, 30, like that, correct? Then we have got the value of I again, okay? But here we are going to use the pointer. Okay, pointer plus percentage D is equal to percentage D is the value of that particular pointer which is pointing to that index. Okay, so star pointer plus I. So it will be pointer plus 0, pointer plus 1, like that. Now, let us first see the output. Then I will just write this in the comment here. Okay, so that you will understand this later. So let us go for the pointer and array. Okay. Fine. So I will just compile this with the, if you don't want that, I can initialize this outside. Okay. So int I, and here I will write I equal to 0. Okay. So that we don't have to give that option. That is nothing but your warning, not an error. Okay. Look here. See, it is just a type of the output format, okay? So air of 0 is equal to 10, okay? Air of 0 is equal to 10. So this 0 and this is 10, okay? And this is Okay, there was some network issue on my end. I hope I'm audible now. Let me share my screen once again. And let me know the screen
Ma'am, actually, in
is
between
visible.
there is a glitch in voice. Hello.
Hello, yeah.
Yes, ma'am.
Yeah, tell me.
Now it's fine, ma'am.
Now is it visible?
Yes.
Okay, fine. So this is what, okay, I've shown you the output. Okay, so actually what is done here? Okay, I'm just going to write it down in the comments. Okay, so air of I, understand this air of I is equivalent. Okay, it is equivalent to star air plus I, correct? And hence you will be getting the output. Okay, so air of I is equivalent to air plus I, right? So you can see the output here. So we are getting star pointer plus 0, which is pointing to air of I only. That means air of 0. Then pointer plus 1, it is pointing to air of 1. Correct. So this is equivalent to printing that, right? Okay, now let us move further. Next, we have got pointers and string. Okay, now we already did with the strings, right? So in C, a string is a character array ending with a /0. That is a null character. Okay, this we have understood. A pointer to char can be used to traverse or modify a string. A pointer to char. Okay, now we have done the pointer to integer in the arrays or in the previous example. Okay, now let us understand pointer and strings. Okay. So whatever we have done, okay, earlier, we are using the pointers with them only. So this will be saved as pointer and string. Okay. So let us use so let us say I'm creating this char str is equal to, okay, let us say C programming. Okay. Fine. Now char star P or pointer is equal to str. Okay. So initially the pointer is going to point to C. Right? It is going to point to C. Okay. Statement. So let me write here string using pointer traversal. Now we are going to traverse using the pointer. Okay. Now look here. For character strings, we are using null terminator, which is /0. Now, while star ptr is not equal to /0, that is the null terminator, we will display the value. Okay, so printf %c k star of ptr. And then pointer plus plus. See, arithmetic operation we are applying here. Okay. So what we were doing earlier, we were not using the pointer. Okay, because we were using that particular array. But now this star ptr is equal to str means this is pointing to the Okay, so it is going to print this percentage C star pointer, right? It will go to the next character, it will print P, then it will go to the R, it will print R, like that. So we have to increment the pointer. Okay, let us see the output of this. So we have got pointer and string. Okay. Okay, look here. We are getting C programming, right? So the only thing is we are using the pointer and we are incrementing the pointer here, correct? So how this is done? So let me just write it down in the comments. Okay, so P or pointer initially points to C. Okay, it is pointing to C. And each pointer plus plus moves the pointer to the next character. Okay, next character till it reaches the slash C. It is not written, but when you give any string in double quotes, anyways, it is the slash 0 at the end. Okay, that we know. Correct. So this is how you're going to get the output of the C programming using the pointer notation. Okay. Then next we have got pointers and functions. We did the functions yesterday. Okay. So pointers are used to pass arguments by reference, allowing the function to modify the original value. So yesterday we have done one example, pass by value and pass by reference. Okay. Now in pass by value, what happens is that the original value is not modified. Okay. Only the target value is getting modified. In the case of call by reference, both the original and the target value is going to modify because both are pointing to the same memory address. Okay, because we are passing the reference and not the value. Now, the same thing we will be doing with the pointer. Okay. So call by value function gets a copy of the variable, original is unchanged. Call by reference using pointers, function works directly with the original variable. Okay. So now what we are going to do here is we will do a example, okay, which is known as swapping. Okay. Now we will swap the values, okay, of the variables. And this we'll be doing by using pointers. This you can do it, okay, what we have done earlier by using call by value and call by reference, but we'll be doing this with the pointer. Okay. So let us create a new file here, right? And I will be saving this file as swap.c. Okay, because we'll be doing the swapping by using the temporary variable. Okay, so this will be swap.c. So now understand this. Okay, yes, you can do it without by using the function, passing the parameters. Okay. So what we will do now, first I am going to create a function. Okay, so let us create a function as void swap. Okay, understand this. We are creating a function about the main. So I don't have to declare the function. I am defining the function. Defining means you are giving the function body. Okay. So int star x. Okay. Then int star y. And in between, we are going to now write the code for swap. So X value we want in Y value we want in X. That is what is the swapping, correct? But how you will do it? You can use the temporary variable. Okay. So initially you can store the value of X in the temporary variable, put the Y ka value in X, and then put the X ka value from temporary to Y. So use a third variable to swap these numbers. Okay. Now, this can be done without using the third variable also. Okay. Int temp is equal to, okay, right? Star X is equal to Y. So Y ka value you are putting into X. Now in Y, you will put the value of temp. Okay. See here. This is how you're going to swap by using the pointer. Okay. Which program, Vinodna, which program you want me to show? Earlier one, pointer and strings. Vinodna, pointer and strings you are talking about? Okay, please write which program. Okay. Yeah, see this one. Okay, this is the one which I have done. Okay, traversing to the string using the pointer. Okay. Okay, fine. So you have noted it down, right? Now come back to our problem. So here I will write in comments, or above I can write in comments for this particular function. This star X and star Y, okay, refer to the actual variables. Okay, refer to the actual variables. Okay, changes will be reflected outside. Okay, now come to the main method. We will give some value to the variable. So I'm giving int a is equal to 5, b is equal to 10. Okay, we are giving a is equal to 5, b is equal to 10. Okay. Printf, before swapping. Okay, before swapping, a is equal to, okay, a is equal to percentage d, b is equal to percentage d. Okay, percentage d. Yeah, any query, anyone? Okay. Then slash n. Okay. A and B ka value. Okay, this is the before swapping ka value. Now call the swap. Okay, call the swap method, and remember you have to pass the address of A, comma, address of B. Okay, so what here we are doing, we are passing the address. Okay, so pass the addresses. Okay, now you will print the value after the swap. Okay, so after swapping, you will print the value. Okay, and here I'm simply writing return 0. That's it. So this will pass the addresses of A and B. Okay, this will pass the address of A and B, correct? So what we are using, okay, we will be now swapping this. So star X and Y refer to the actual variables, correct? Before swapping and after swapping. So let us now compile this. So we have got a swap. Okay, so GCC swap.c. Okay, A. Look here. Okay, so before swapping, value of A is 5, B is 10. And after swapping, we are getting A is equal to 10 and B is equal to 5. Okay, A is equal to 10 and B is equal to 5. The swapping has been done. Okay. So this will point to the actual variable. Okay, actual variables. So changes will be reflected after you are calling this. Okay. Okay, what is the query? Let me just, Manjula, which link you are talking about? Costa. We are using pointer, Costa. Okay, we are using the pointer. Okay, and that is why we are using this star. It will point to the actual variables. Okay, now if you are not using this pointer, okay, and simply I'm using this, okay, and here we are using A and B, right? See, I'm doing this without anything, right? Okay, so we are getting the value A is equal to 5, B is equal to 10. And after swapping also A is equal to 5, B is equal to 10. Understand this. This is, we are passing the values. So swapping will happen where? Swapping will happen here only, right? So A has got the value, sorry, X has got the value A and Y has got the value B. Correct? Yesterday we did with only one variable. Now we are doing with the two variable. Now, if you want, okay, I will print the value of X and Y here. Okay, so look here. So here we will display the value of X and here we will display the value of Y. Okay, so let us write here X and Y. Okay, fine. Now let us see. Cause to understand this, what we are doing, we are passing the values, and if you don't specify address, it is passed by value, correct? So A value is going into X, B value is going into Y. So before you call the swap method, A is 5, B is 10. After swapping, X is 10 and Y is 5. Because it is happening here. It is not happening to the original value because we are passing the values by value, not the references. And after swapping, A is equal to 5, B is equal to 10. This is the original variable. Now to understand, here I will write inside the swap. Okay, inside the swap, okay, after swapping. And this is the original values. Okay, this is the original value. Original values of A and B. Okay. Fine, please understand, this is call by value, where only the target will change, not the original. This is same thing. Okay, so inside the swap method, the target variable X and Y will be swapping, but A and B, which is the original, it is not going to change. Correct? Now, if you are passing the address, means the modification is going to be done on both original as well as target, because you are passing the address now. You are not passing the value. In case you are passing the value, the memory address of A and X is different, B and Y is different. But when you are writing @A means now A and X will point to the same memory address. So it is going to affect both the location. B and Y will be pointing to the same memory address. Okay. Now, if you are using @A and @B means you are passing the addresses. Now what will happen? Okay. See. Now, if you are using the address, you need to make use of pointer, dereferencing, and that is why we are using star. Yesterday is the same thing we did in the function. Okay. So if I go to the day 8, okay. If you go to the day 8, we have done call by value and call by reference. Okay, let me open this. Look here. We have passed only one value. Okay, and we have to use here what? Star. This is a dereference operator. So whenever you are passing address, you need to use this particular pointer, dereference. Then only it will point to the actual value. The same thing we are doing here. Okay, so here everywhere now you will be using star so that it is pointing to the actual variable whenever address is used. Otherwise, it is not required. Okay, but then it will be the simple pass by value only, na? Call by value. Okay, fine. So now both the location, the changes are going to happen. Okay, now see here. Fine. Now we are using the pointer, right? And that is why we are getting this particular address. Okay, not the actual value. So you can write star of X and star of Y. So here this is changed and this will be swapped. Swapping is done now. Okay. I hope this is clear now, Kaustav. Yes, yes. You have to use star if you are using address. These two are the pointer operators. Okay. Fine. Now let us go to the next topic, which is void pointer. Okay. So there is a void pointer and there is a constant pointer. Okay. This is also very important concept in the pointer. A void pointer is a pointer that can store the address of any data type. Remember, in a function, when we are writing void, that we did yesterday, okay, we have created the functions which are returning void. Look here, this is a void function. Means it is not returning anything. Correct. If you're writing int, that means it is returning an integer. But the void pointer means it will point to any data type. So what we did now, we created the integer pointer. We created the character pointer, right? We have been specific, but if you want to store the data of any data type to the pointer, use void pointer. So what are the key points to remember here? A void pointer does not have a type. So C doesn't know how many bytes to access. Cannot dereference a void pointer without casting it explicitly because the data type is not known. Very useful for generic data structures where type is not mentioned. Malloc and flexible functions. Okay, we will do the malloc, calloc later on. This is all related to your memory. Okay, but we will do a simple example as of now of void pointer. Okay, so let us create a new class. All these type of the pointers are important, okay, to know. Let us say I'm going to have 3 different data types ka value. Okay, so I'm having int a equal to 10. Okay, let us have float b is equal to 5.5. Let us have char also. Okay, let us say char is having a. Okay, so what I'm having all the different types ka data. Okay, so this will be void pointer. Okay, this is a void pointer, correct? Now I'm going to create a void star pointer. Now this is a generic. Generic means which is applied to all. This is not specific, right? I have not written int pointer or float pointer or char pointer. It is void. It is generic. So this is a generic pointer. Okay. Now what? Now if you want to point this pointer to int A we have created, correct? You will write, okay, let us do one thing. Let us give the pointer name as v pointer. That is a void pointer, okay? So that it is understood. So void pointer is equal to address of A, okay? Now, if you want to print the integer value, okay, of the pointer, what it is pointing to, star vptr, okay, but this will not work, okay. I will just write it down and show you the output first. So this is a void pointer, okay. Look here. Here it is written that invalid use of the void expression, dereferencing void star pointer. Now, whenever you want to have the value of the void pointer, since void means it is not a specific data type, so if you want the actual value of the specific data type, you need to typecast this. So how you will typecast this? You have to write that this v pointer should give the integer. This is the cast. Okay, so this is explicit casting you need to do. Okay, so this is cast which is required here. Fine. Now let us check. I'm getting the value 10. A is pointing to 10. Okay, because it is a void pointer. It is not a int pointer. If you are writing int, so directly I get the value, right? But now we need to typecast this to the int star. Okay, similarly, let us do with the float and the char. Okay, so I will be now using address of B. Okay, now I want the float value here. So you typecast this to the float type. So here you will be writing float. And similarly, if I want to point this to char, so this will be float. Okay. And this is pointing to char. Right. And what we will do here, this is a char value. Okay. And here we will be using character pointer. Okay. So let us now check whether we are getting all this. So this will be C. Okay. C is the character. Okay. So let us check this now. So in the case of void pointer, you need to use the typecasting. Okay. I'm getting here 0 because we are using D, and here I need to use C for getting the character. Otherwise, you are getting what? You are getting 65 because capital A ka ASCII value is 65. This we did. Okay. So if you want the actual value, use the proper format. Okay, now I'm getting it. Right. So 10, float value is 5.5, char value is A. Void pointer. Okay. And last one is the constant pointers. Okay, last one is the constant pointer. Now, what is a constant pointer? There are 3 important variations when you are using the constant with pointer. Now, remember, We did with the constant. Constant means what? The value is not getting changed. That is what is the constant, correct? So here, okay, I will, yeah, this is the program. This is the program. Vinutna. Okay. Fine. Now let us come to the last topic. Pointer to a constant value. Please understand the terms which are used here, okay? Cannot change the value using the pointer. Pointer can be pointed to another variable like constant int star pointer or int constant pointer. So cannot change the value using the pointer because it is a constant. We cannot change the value. But pointer can be pointed to another variable. Okay. That is pointer to a constant value. Then constant pointer. Pointer cannot change its memory address because pointer contains the memory address. It cannot change the memory address, but can change the value at that address. So the pointer is pointing to an address. Address cannot be changed, but value can be changed. That is known as a constant pointer. That pointer ka address cannot be changed. So int star constant pointer is equal to address of A because now address is given to the constant pointer. Na? So address cannot be changed. Constant pointer to a constant data cannot change the value or the pointer address. Constant int constant pointer is equal to address of A. So if constant pointer and constant data is given means you cannot change the address also, you cannot change the data also. Constant pointer means you cannot change the address, but you can change the data. Constant value means what? You cannot change the value, but the pointer can be pointed to another variable. Okay. Now to understand this, let us write the program. Okay. So let us save this as the constant pointers. Okay. .c. Now I will be creating some 3 methods here. Okay. So what I'm going to do is we will create some 3 methods. Okay. And then I will write the comments. So first one is constant to value. Okay. All the 3 we need to understand. Second is constant pointer. Okay. Constant pointer. Third is constant value and constant pointer. Okay. So we can have a constant pointer and constant data. Okay. Both cannot be changed. Both cannot be changed, right? So let us come to the first one. We have got int a is equal to, let us say 10. Int b is equal to, let us say 20. Okay. Constant int pointer is equal to address of A. Constant int star pointer is equal to address of A. It should be address of A. Okay. This is pointer to a constant int. Okay. Star pointer is equal to 30. This is not allowed. This is not allowed. Okay, so I will comment this part as of now. Pointer is equal to address of B. This is allowed. Okay, pointer can change. Okay, and finally, I will printf the statement value pointer points to percentage d / n. This is pointer. Okay, understand? This is not allowed. Okay, you cannot change the value because it is constant to value. You cannot change the value, but you can change the address. Okay, so pointer can point to address of B. It was earlier pointing to address of A, but it can point to address of B, but it cannot change the value of that particular address to which it is pointing to. Value cannot be changed. Okay. Now let us copy this and I will go for the constant pointer. See, you have to remember according to the terms, whatever are used. Okay. Now A and B ka value is going to be same. Okay. Int star constant PTR is equal to address of A. Okay. Now this is a constant pointer. Star PTR is equal to, let us say, 50. Pointer we are changing to 50. Okay. This is allowed. Okay. Value can change. This is allowed, value can change. But PTR is equal to address of B. This is not allowed. Okay, address cannot be changed. Right? So I will comment this part. Okay, and now we will display the value. So value of A I want to display. Okay, so I'm going to display the value of A. Okay, so remember, in constant value, we cannot change the constant value, what it is pointing to, but we can change the address. Okay, what the pointer is pointing to. Here, we can change the value, but we cannot change the address because it is a constant pointer. We can change the value, but we cannot change the address. Now coming to the third. Okay. Here, both cannot be changed. Correct? So this is a constant pointer. Okay, let me just delete all this. So constant in star constant pointer is equal to address of A. Okay, what is not allowed? Both are not allowed. So if you are writing star of pointer is equal to 30, means you are changing the value and you are changing the address of the pointer to B. Both are not allowed. Okay, not allowed to modify. Value is constant. Here also not allowed. Pointer is also constant. Okay. So this both are not allowed. Okay. And now if you want to print some value here, pointer ka, you print that. Okay. So printf value percentage d / n. See, if you want to see the error, you need to uncomment that lines. Okay. So what pointer is pointing to, we will give the value. Now, since I have written this in all the functions, simply call the functions. First is constant to value. Second is constant pointer. Third is constant pointer and constant data. That's it. Okay, now let us run this constant pointer. Fine. Now we are getting, so value pointer points to is 20. Okay, because pointer is now, it is pointing to 20. In the second case, value of A is 50 because pointer is pointing to 50. Okay, address of A. But later on, we change this value to 50. So we are getting 50. In this case, address is A. So that means pointer contains the value 10. Now, if you want to check, okay, you can just uncomment this and see whether this is allowed or not. So in the case of constant to value, you cannot change the value of the pointer which it is pointing to. Okay, pointer is pointing to address of A. Address of A means it is having the value 10 and you want to change that value to 30. This is not allowed. Okay, so because it is a constant integer. So similarly, what you have to do is you have to uncomment all and then you check. Okay, so assignment of read-only location pointer. So this error you will be getting. Okay, this is not allowed. Fine. So this is what is the constant pointers. Okay, where it is allowed to change, where it is not allowed to change. So finally, this is the comparison table. Okay, for all the different types, whatever we have done today. Operators that work with the pointer. So address and the star, dereference operator, pointer arithmetic. Okay, moving to the next or the previous. Pointers and arrays. Okay, so pointer will always point to the 0 index ka value. String will be also pointing to the 0 till it is reaching /n. Functions, we have used the swap example, pass by value, pass by reference. Generic pointer can point to any type of the data, but you need to typecast that to get the actual value. And constant pointer are of 3 types. The value is constant, you cannot change. Pointer is constant, you cannot change the address. And in the last case, you cannot change the address also, you cannot change the value also. Okay, so these are the pointers concept, right? I hope this is understood, everyone. Okay, attendance link is shared. Fine. So I will share this particular programs, but the assignment, okay, for functions and pointers that I will be sharing, maybe in, okay, Monday you will get that. Okay, so try to complete the assignments, okay, for the previous topics, whatever are given. Okay, so this also will be shared. So I will share all the codes, whatever today we have done. Okay, so that you can work on this, right? Okay, Jyoti. Okay, so I'm going to stop. So next week, we will have the important some advanced topics like union, structure, reading and writing to the files, that is file handling, memory management, preprocessor, okay, and error handling, right? Okay, fine, everyone. Where to see the notes? Ashwini, everything is given in the LMS. Everything is updated in the LMS. All whatever The programs I'm doing, it is shared over there. The assignments, what I'm giving, that is also shared. Okay, the last two functions and pointers assignment I need to give, that also will be shared. Okay. Ashwini, in your LMS, you will be able to see that. So Amar, you can help out Ashwini in getting the notes on LMS.
Yeah, sure. So
Ha.
Ashwini, if you're struggling with the LMS portal anywhere, so you can just drop any email. So our team will
Right,
meet with you.
right. Okay. Fine. So we will connect on Monday now. Okay, that will be the last week of the training. And so before that, please go through all these examples, try to solve the assignments. Okay. And why? Because in the next week, you will have the project also given, which you need to do later on. Okay, that is up to you only, but you have to, do that and work on the assignments. Okay, fine. So we'll stop here. Thank you, everyone. Connect on Monday. Thanks all.
Thank you, ma'am. Thank you, students. See you on Monday.